All right, mathletes, here we are looking at graphs of quadratic functions. So the simplest quadratic function is our y equals x squared. We want to look at the graph. One way of doing it is substituting in values of x, okay, finding the y values. So negative 3, plug in here, negative 3 squared is 9, negative 2 squared is 4, negative 1 squared is 1, and so forth. Okay, using these values, their coordinates, this is an x coordinate, this is a y coordinate, I can go ahead and graph it. So over here on my graph, I can go over 1, 2, 3, minus 3, and up 9, and I have a point at negative 2, I'm at 4, and at negative 1, I'm at 1, at 0, I'm 0, 1, I'm 1, 2, I'm 4, and 3 and 6. Notice the symmetry involved here with the parabola. Okay, what's really nice about the symmetry is we always have points that are the same distance away from our line of symmetry here. Okay, notice our vertex is always the turning point. So from this vertex on the left side, okay, it was decreasing. Okay, on the right side, it was increasing. Okay, so that point we call the vertex. So let's look at an example of how we can graph by using a table. So draw the graph y equals x squared plus 2x minus 3 using a table of values from x equals negative 3. So I started my table from negative 3 to 3. So I plug this in, I'm going to get y is equal to, so I get negative 3 squared plus 2 times negative 3 minus 3. This is going to be equal to 9 minus 6 minus 3, which is equal to 0. So at negative 3, I'm going to go ahead and graph that point. At negative 3, I'm equal to 0. Okay, so do that again, now with negative 2. So I get negative 2 squared plus 2 times negative 2 minus 3. I'm going to get 4 minus 4 minus 3. So that is going to be minus 3. That was minus 3. Let me add 0 here. Okay, so let's go ahead and figure out negative 1. So negative 1 squared plus 2 times negative 1 minus 3. This is equal to 1 minus 2 minus 3, which is equal to negative 4. So at negative 1, I'm negative 4. Okay. And then I'm going to plug in 0. Well, I have 0 squared plus 2 times 0 minus 3. This just ends up being minus 3. Okay. Now let's plug in 1. So I get 1 squared plus 2 times 1 minus 3. So this is 1 plus 2 minus 3. This is equal to 0. So at 1, I'm equal to, that doesn't seem right, 0. Oh, I've graphed this point wrong. This was supposed to be negative 3. So it's negative 4, negative 3, and now this is here at 0. Okay. And then at 2, I'm going to do 2 squared plus 2 times 2 minus 3. So this is 4 plus 4 minus 3, which is going to be equal to 5. So at 2, we are equal to 5. Okay, and then at 3, so I get 3 squared plus 2 times 3 minus 3 is equal to 9 plus 6 minus 3 is going to be 12. So I'm going to be off the graph somewhere over there. Okay. If I connect my dots, okay, notice I have my parabola. I can see that this is my vertex here. So notice as I go left from my vertex, I go up 1. As I go left of my vertex, I go up 1 and right 1. Okay, as I go over 2, going up 4, going up 4. Okay, and then if I carry this symmetry over, okay, here I know I'm going to be at the same point up high over here as there. And I can get my parabola to look like that. So that's how we can graph a parabola using a table of values. This is the end of our notes, so highlight any questions you might have and bring them to class tomorrow.